This is Dr. Inez Flaw. I'm a professor at Purdue University, and I have spent some time at Climate Earth as a visiting scholar in water and toxics. I've collaborated very closely with Dr. Corinne Reichweiser, Vice President of Research at Climate Earth, and we are now releasing the second in a series of white papers. This one is entitled Measuring Total Corporate Chemical Emissions to Water. And it's a follow-on paper to our first white paper, which focused on water consumption solely. And this is a focus on emissions to water that is discharged. So why measure chemical emissions to water? As part of the current dialogue about global water use, we need to consider the human impact on water quality and quantity. Total water withdrawals for all purposes in the U.S. recently amounted to 127 trillion gallons in a single year. How did fulfilling useful purposes change the quality of that water? Consider a national report by the U.S. EPA, part of their national analysis of the toxic release inventory data. New for the 2009 analysis is large aquatic ecosystems and the chemical emissions to those ecosystems. As you can see from the chart created and distributed by EPA, the Gulf of Mexico is the top ecosystem in terms of millions of pounds of chemical discharges to that watershed or collection of watersheds, followed by the Great Lakes. Also interesting to note is that emissions to air and land sometimes are much larger than emissions to water, but in many cases, because of mass transfer, these chemicals end up in the water and have impacts. So chemical emissions impact quality, and because businesses need sufficient water quantity and quality to support their own operations and their suppliers' operations, it's important to estimate total chemical emissions, as well as measuring total water consumption. Most organizations can accurately measure their direct discharges. It's much more challenging to calculate discharges to water by their suppliers. In this white paper, we talk about methodologies for calculating chemical discharges to water, which contribute to environmental damage such as eutrophication and ecotoxicity, and to human health effects. The methodology applies to the emissions that contribute to these very different categories. Eutrophication is the accelerated aging of surface waters due to excess nutrient loading. Ecotoxicity, in our context, is damage to organisms that live in freshwater ecosystems. And human health effects include cancer and non-cancer types of diseases. So we're going to also see how simple actions, such as dematerialization, result in reductions throughout the supply chain. So one very important analysis and an important theme throughout the paper is using our methodologies to allow companies to understand how they can balance consumption versus emissions impacts. This is a supply chain map of the eutrophication potential for an average U.S. automobile manufacturer. What this represents is the eutrophication potential throughout the supply chain due to discharges in each of these supplier categories. Recall that eutrophication is the accelerated aging of surface waters due to discharges, generally inorganic, generally nutrients. So the large gray bubble in the lower left, labeled automobile, represents the sum total of the eutrophication potential from direct and indirect operations supporting the manufacture of automobiles. This is the sum of all Tier 1, the blue bubbles, surrounding the gray bubble, including inputs such as leather, carpet, wholesale trade, textiles, and auto parts. These Tier 1 suppliers are then supported by Tier 2 suppliers, shown in green and pink, and the Tier 2 suppliers are supported by Tier 3 and Tier 4 suppliers as we move down the supply chain. So this is an important balance to a very similar supply chain mapping of water consumption, which we show in our white paper. We do a detailed analysis of consumption and eutrophication, and those impacts are maximized at different points in the supply chain, and the direct and indirect impacts are quite different. That is, the proportionality of direct and indirect varies a lot, whether you're considering eutrophication or water consumption. So for the auto manufacturer who wants to balance these impacts, make decisions about reductions, this type of information can help the manufacturer set sustainability priorities. Eutrophication is one example of an environmental impact category that can be quantified with these methodologies. Others, as I mentioned earlier, include ecotoxicity and human health effects. And in our case studies of dematerialization and other actions that a company can take, we'll also look in greater detail at these impact categories. At the end of the white paper, we discuss examples from two industries, the beverage manufacturing industry and the amusement and entertainment parks industry, where simple decisions within the company can result in chemical emissions reductions throughout the supply chain. So download the white paper now by clicking on the link in your email. We hope that the white paper will be extremely useful to your business.